Hello, this is Math 2134 coming to you from the College of DuPage during the fall of 2020, and this is the conclusion of the lecture entitled Functions, Domains, Ranges, and Such. The graph of a function of one variable, and the function is called f, is a set of all points xy in the xy plane such that x is in the domain of the function and y equals f of x. So here's the picture. You can see that the x values that you visit on the graph as you run along the graph are the domain, and the y values are the range. Here's an example for you to do. These are the kind of questions I might ask on an exam someday or on a quiz. You know what to do. Let's see how you did. Well, from the graph we can see that f of 3 is minus 2 and f of 5 is 3. And since the point 3 minus 2 is below the x-axis, the depth of the point 3, f of 3, is 2 units below the x-axis. And this point 5, f of 5, lies above the x-axis, and so it's located at a height of f of 5, or 3 units above the x-axis. When you look at the domain, you can see that the x values that you run from are minus 1 to 7, including the endpoints. The y values range from minus 2, the lowest, to 7, the highest. Here's another example. You just sketch this graph and identify the range. You know what to do. Let's see how you did. Well, this is a parabola opening up, and it's like y equals x squared, except it's shifted up 1. So the graph's going to look like this, and you can say, what y values do you visit? And you can see that the y values you visit are from 1 all the way up to infinity, and it does equal 1, so it's bracket 1 comma infinity. Sometimes a function is defined by giving different formulas for different parts of its domain. Such a function is said to be a piecewise defined function. So here is a piecewise function for you to sketch the graph. You know what to do. Let's see how you did. And so the graph looks like this. You can see that the domain is all real numbers. You can see that the range is greater than or equal to 0, and there's what the graph is going to look like. Later on, an abrupt change like that will be an important consideration for us as we talk about the derivative. And life is a word problem, and so here is a word problem for you to do. I think you're supposed to sketch the graph. Yes, that is right. You know what to do. Let's see how you did. So the graph of this is going to look like the square root of 2x, so it's going to be growing slowly until you get to 2. And then at 2, it takes off looking like a parabola. And so there's where the graph changes, and those are the values that you see. Although it's true that every function f of a variable x has a graph in the xy plane, not every curve in the xy plane is a graph of a function, because a function can only have one value, and you can see here that many of the values, like here we can see that this particular value of x would have two y values. So this motivates the idea of a vertical line test for determining whether a curve is a graph of a function. And the curve in the xy plane is the graph of a function y equals f of x if and only if each vertical line intersects it in at most one point. So here you're supposed to determine which of these are graphs of functions. You know what to do. Let's see how you did. And the only one that's not a function is b, because this fails the vertical line test. In closing, now more than ever, time is precious. Each day must count. Do the math. It will make you strong. And now more than ever, take care of yourself and of each other. God bless you all.